everyone. I'm Daniel. I'm a software engineer at Hyperlane. We're this interoperability protocol. And presentation today is titled Modular Blockchains and Permissionless Interoperability. We're going to cover like 3 topics. First one is kind of like an overview of what modular blockchains are and why they're all the hype nowadays. And then I'm going to tell you about what it is we do at Hyperlane. And at Adrian's request, I'm going to cover Celestia as well, which is maybe the most prominent project in the modular space nowadays. So let's get started. In this world of ours, we have these things called internet computers. And they're really cool, starting with Bitcoin onwards to Ethereum and Cosmos and so on. For the first time in the digital domain, they introduced this notion of scarcity, which enabled things such as sovereign money, permissionless access to computation. But by the very nature of something scarce, we eventually end up fighting for it, as it is the case with permissionless computation. Like, we have a certain amount of block space available to us, and we want to do too many things than the networks support. I really like this image, which visualizes Ethereum. Does this work? Visualizes Ethereum blocks and Bitcoin blocks as buses on a street, and then transactions of different sizes visualized as these South Park-looking characters that are trying to get on the bus. And in real life, when the bus is full, it's full. You have to wait for the next one. Whereas in blockchains, we have this notion of surge pricing. So the more people want to use space in a block, the more expensive it's going to be. And I'm sure, like, raise your hand if ever, within the past few years, you wanted to send a transaction but didn't because it was too expensive, just the fees. I think this is where we're starting from. The gas is too damn high. Like, sometimes it costs more to send a transaction than it does, than the money you're moving around. So our space has this scalability problem, and it's been acknowledged for a long time now. And there's been many minds at work trying to fix this, with the solution that everyone converged on in recent years being rollups. And rollups are this way to scale, I guess, starting with Ethereum, but now moving to other chains. So how do we use the security we get from Ethereum in terms of secure block space, but still make it cheaper to send transactions? And the first way rollups were implemented was to take the execution out of Ethereum and then post it back to it. So in a bit more detail, basically rollups are what we call layer 2 because they live on top of a layer 1. They draw their security from the layer 1, which is Ethereum. And the way they work is that you have those South Park characters, those transactions. You have them, and instead of sending them to Ethereum, you send them to the rollup. The rollup really is, in most cases, a service called the rollup sequencer. And say that rollup is Polygon. Instead of sending your transactions to Ethereum, send them to Polygon. It will execute them for you. And when it's done doing that, it will post a compressed transaction batch to the Ethereum chain in a smart contract that corresponds to the Polygon rollup. That makes it cheaper because now you no longer need to have every node in the Ethereum network do the same computation for you. You just post a proof that that computation happened along with the data associated with those transactions. So if we like to categorize these things, these duties that we just described, you kind of have the sequencer node in charge of transaction execution. Then when it's done doing that, it's going to post the compressed batch to the contract, the rollup contract on the layer 1, and that is in charge of validating that the transaction was okay. In the rollup world, there's really kind of like 2 flavors of validating. if you've heard the notion optimistic rollups and ZK rollups. There are different strategies. And that's, wow, this font is really messed up. Like these are all lined up super nicely, but it's what you get. And transaction validation is also called settlement. And then you have the layer one, basically Ethereum in this example, in charge of ordering the blocks from the rollup that you post to it, and then making the rollup transaction data available for validating. In more formal terms, the sequencer is in charge of an execution layer, then the rollup contract is in charge of a settlement layer, and the layer one is in charge of a consensus layer and a data availability layer. And I'm gonna explain these in more detail in a bit. So if you really kind of try to think about the functions that the blockchain fulfills, you can split them in these 4 categories. And now the thesis that the Ethereum community has tried to build on more recently is how can we decouple these functions of a blockchain from a layer one like Ethereum and try to specialize them rather than bundling everything into one in a hope that we can make everything more efficient and cheaper. And so rollups like Polygon, like the first version of Polygon, decoupled execution and left everything to Ethereum. But nowadays, for instance, with Celestia, we can decouple consensus and data availability and really, really optimize that. So that's kind of the brief introduction to the modular world. I'm sure you'll get an even better understanding as we proceed. And so where does Hyperlane fit into this? We'll eventually end up with lots and lots of rollups because so each of these layers gives opportunity for innovation and everyone's going to do it slightly differently. This is why you have specialization and different trade-offs. And everyone expects that we'll soon be living in a world with hundreds of rollups, if not thousands. But the drawback that these rollups bring, like while they significantly lower transaction fees, they kind of segregate storage. So you no longer have, say, DeFi apps that all have a shared state on the Ethereum L1, and they can, have like money Legos and move data around. You have the data fragmented across rollups, and with it you have liquidity fragmented. And if you've used DeFi apps before or like are familiar with economic theory, you know that when liquidity isn't deep enough, like it's fragmented, that's when price shocks are most likely to happen. That's when ecosystems get destabilized, margin calls, and so on. And so what do we do if we have very cheap transactions, but very risky ones? Because there's no way to move assets around between these rollups. So this is the thesis we're trying to build on at Hyperlane. We're kind of this framework for allowing any new rollup to deploy a bridge to anywhere they want, such that we can make this modular future a reality. Because you can't have a modular future if rollups are all fragmented, right? We like to think of ourselves as this interchain highway where every rollup is like a planet and you connect all of them with 2 new features that we bring to the market. One is what we call permissionless interoperability. Nowadays, if you want to deploy a bridge between 2 chains, it takes months of business development work, like playing politics with that project to deploy on your chain. But we want to make that fully permissionless, like you don't depend on us to deploy a bridge. And in order to make this a reality, we're also shipping what's called modular security when you send messages between chains. Let's see, so given this modular stack, we think that the missing piece for scaling rollups and making the user experience and the economic security of it a success is to add interoperability as the last layer in the modular stack. Why, you may be wondering, like, this sounds pretty obvious and straightforward. Why didn't someone else try to do this so far? And the reason, we think, is because for all of these bridging providers, like say Wormhole, Axelar, and so on, they couple the security of their bridge to their messaging interface. That is, you integrate with the Axelar smart contracts, and then no matter where you send your messages or like the value that your messages transfer, you're always going to have to pass through their validator set that signs your messages. And think about, with, again, hundreds of rollups, if you want to add support for a new, potentially obscure rollup, how are you going to convince the validator set of that bridge to be willing to run software for that one additional chain? Because that one additional chain obviously means extra infrastructure costs for them. It means maybe having to pay an RPC provider and so on. And that takes a lot of convincing to do. Which is why we decided the only way forward, if we want to allow these rollups to interconnect, is to decouple the security of sending messages between chains from the interface. So you integrate with the Hyperlane set of smart contracts, but then maybe depending on the destination, you use a different validator set. This is kind of the thesis that IBC pushed in the Cosmos world and was very successful in doing so, but there was no one who managed to do this outside of Cosmos. So this is one example of how modular security can be useful, per destination security. And let me give you a different example where modular security can be very useful. I'm sure all of you have bank accounts, and you've experienced what it's like to send maybe 10 euros to someone you know. Like, it's super smooth. It just goes right through. There's no issues with it ever, because even if you send that money to a scammer, it's just 10 euros. Like, at the end of the day, it's no big deal. Whereas what happens if you try to send, say, 50,000 euros? Well, first of all, your transaction is probably going to get blocked, and you're going to get a phone call from your bank or an email. They're going to start asking you all sorts of questions, like, is that really you who initiated that transaction? And after a lot of back and forth, maybe eventually they will let that transaction go through. But it's way more complicated to send that amount of money than it is to send 10 euros. And it kind of makes a lot of sense. But we don't have that in crypto when you try to bridge funds. Like, if you send 10 USDC or 100 million USDC, we apply the same level of security to it, although we shouldn't. Like, when's the last time that a 100 million USDC transaction wasn't a scam or a hack? It's probably always a hack, right? So in that case, maybe you want to allow a longer time window before that transfer goes through for people to actually check what's going on. So there's two scenarios for why modular security could be useful. Allow you to bridge with different security between different chains, so you don't have to lobby validator groups, and contextual routing based on message value. And nowadays, based on this rollup thesis that's being pushed by Ethereum, like the Ethereum Foundation and everyone else, it's very, very easy to launch a rollup. And Ethereum is going to become a hub for rollups. Cosmos is going to become a hub for rollups, and so on. But like, what good is it to launch a new rollup in 15 minutes with one of these SDKs or frameworks if it's going to take then like weeks or months to convince a bridging provider to actually deploy a chain for you so that you get easy access to users and to liquidity to bootstrap your project? Like, we think, again, for this to succeed, we need to allow this plethora of rollups to connect as quickly as they're able to deploy their rollup to anywhere they want at any time, so without asking validator groups for lobbying. Just like as an overview of how the Hyperlane protocol works in the most basic sense, there's a mailbox contract that lives on every chain. And say you're on chain A, you send a message to the mailbox contract that you want to have arrive on a destination chain. And it will eventually arrive in the mailbox at the destination. Then the mailbox, what it does is it asks the recipient, here's a message or like something I want to send you. What's the security model or module that you want to apply to it? And as we discussed, it might be that depending on the origin, you might have a validator set for this chain, sign this message, or maybe based on the amount in the message, you have a small multisig or this optimistic window and so on. And if the message does pass whichever security module is specified by the receiver, then the message is forwarded. And the missing piece in this diagram, you may have wondered, like, how do messages get from one chain to the other? There's this service called the relayer that periodically scans mailboxes for outgoing messages. And if your message includes a tip for the relayer, it's surely going to send it across for you. You can relay your own messages, like this is a trustless entity. But like, you may send the message with no tip for the relayer. Maybe it will still deliver it for you because it thinks that there's going to be some MEV opportunity on the destination chain once it does deliver your message. And to recap on the sorts of modular security you could have due to Hyperlane, you could have maybe staked validators, which are then slashed if they sign a message that didn't actually prove to be there. You could have this optimistic window that I just messaged, or a multisig. In one of the newer, like the V3 version of Hyperlane, we enabled wrapping external providers, such as Wormhole. Like, you could integrate with Hyperlane, but if you really, really like Wormhole, you could still send your messages through them. And you're probably wondering, well, that doesn't make any sense. Like, it will just end up costing me more gas to use a provider I already use. But the reason you'd wrap an external provider with Hyperlane is because upgrading to a new provider is very easy. You don't need to break your smart contracts, like release a breaking version of your protocol and audit it again and all of that. Changing whatever provider is wrapped by Hyperlane is as easy as changing a call parameter when you call the mailbox. So then maybe you start off with Wormhole, but there's a new bridging paradigm that becomes super mainstream, like a form of ZK bridging that you want to upgrade. And you're going to be able to do that merely because you integrated with the Hyperlane contracts, which allow you to do modular security. So then changing providers is as easy as changing a parameter call rather than releasing a breaking contract change. And all of this combined, I think the coolest thing ever is that Hyperlane allows you to aggregate these modules and providers. So again, say maybe you really like Wormhole, but are concerned that they might get hacked and have their bridge drained. Well, in that case, you may want to actually aggregate whatever message is passed through Wormhole with messages validated by the multisig owned by your company or like by your DAO. And in that case, if Wormhole does get hacked, it's highly unlikely that the hackers are also going to get majority access to your multisig. So messages are going to get across via Wormhole, but if your aggregation module requires 2 out of 2 checks to pass, your company multisig is obviously not going to send bogus messages, and so your funds are still safe. Cool. That was kind of like the technical overview of Hyperlane. And as you probably all can imagine, if we do manage to get interop fixed for these rollups, then the future looks really, really bright, because you can have all of these applications that used to live on the same chain and be enabled by the fact that they are co-located on the same chain, suddenly become cross-chain and doable, such as interchain DeFi, where your collateral lives on one rollup, but then you take out a loan on a different rollup. Or interchain DAOs, where your DAO maybe lives on, say, Arbitrum, but it has accounts on every rollup in existence, and your DAO can initiate transactions on Arbitrum, which are then propagated to every other rollup that is supported through Hyperlane. Or interchain oracles, like you're going to launch a new rollup, but you're not going to have chain link feeds on it from day zero, because again, it takes a lot of convincing to do that. And you can bring those feeds to your rollup with Hyperlane. And the end game for us, beside what I just explained, is to have relaying services. So have different relayers maybe compete for the lowest fee to send messages across chains, similar to how validators in proof of stake compete for the lowest cut when you delegate to them. We want to have a security module marketplace. All the modules I just described already exist, like the multisig one and so on. But for instance, one of the modules we're working on, and we have external members of the community build ones as well, is an eigenlayer module. Like eigenlayer is all of the hype these days, right? And you want to be able to use restaked Ethereum to do all sorts of things. Well, validating for Hyperlane bridges will be one of those things soon enough. And then the last but not least thing, we wouldn't be, I guess, talking about crypto in 2024 without thinking about interchain intents. That's it about Hyperlane. So far we've covered modular security, modular chains and why we have rollups and why they're the future. We've covered how Hyperlane connects those chains, but let's now understand what really makes rollups kind of unbeatable from a price standpoint and kind of the revolution, I guess, that Celestia brought about. Reminding ourselves of the modular thesis, we have these different layers in a blockchain, basically different functions that are starting to be decoupled. And Celestia found a way to decouple consensus and data availability in a way that's really, really cheap to send transactions on a rollup. If you're familiar with like computer networking, this modular blockchain thesis actually isn't so new, because this is how we send data across the internet today. Like at the most basic layer, you have physical infrastructure like cables and on, and then up the stack you have maybe TCP and UDP, and at the application layer you have HTTP and all of the other protocols. And at every layer in the stack, you could choose one protocol for the other, understanding what the trade-off is. And it's kind of very similar for the future we see for rollups. And so, sorry, let me just, if you want to take a and so given that and the fact that Celestia decided to modularize or like to specialize in data availability, what is it? It's a specialized blockchain. Again, it provides consensus and data availability without having support for any sort of smart contracts. And it's built with a modified version of the Cosmos SDK. And so you might be wondering, what is this data availability? Why is it so important? And why is Celestia like the most famous project in this space? And many people confuse data availability for data storage. And I'm going to try to explain to you why that's not really the case. So you have a rollup. If you remember that diagram from the very start, you have a rollup with a bunch of transactions. It executes them and then posts a proof that those transactions were executed on the layer 1. For the layer 1 contract of the rollup to be able to verify the correctness of those transactions, it needs the transaction data. But after the check happened, you can kind of prune that data away. Like you don't really need it. It bloats storage on the layer 1, which makes it really expensive, both for yourself and for everyone else to transact. So data availability means that all of the data that the rollup claims to have posted was indeed posted. It's a guarantee. And it's a guarantee that data was posted only for an interval of time, maybe 2 months or so. Just enough time to give everyone else the chance to verify that the rollup is doing what it says it's doing. Maybe you want to be able to reconstruct rollup state by checking only what's on the L1 because you don't trust the sequencer. This is what it allows you to do. But again, like down the line, all of this data could be pruned. So this isn't a storage solution. It's just a way to very quickly verify that everything the sequencer posted is there. Cool. And then, okay, that sounds like it makes sense, but there's already many chains that potentially do that. Why is Celestia different? Well, so Polygon V1, right? All of the transaction data was posted on Ethereum. That was super, super expensive because it's replicated through all the nodes, and all of them have to make that check that the data is there. It doesn't really scale. The way Celestia is different is that it implements this technique called data availability sampling, which doesn't give you a full guarantee, only gives you a probabilistic guarantee, but which is so strong that it's as good as a full guarantee. And it scales the more nodes run this data availability sampling. The way it works is that you need some very lightweight nodes, like you can run them on your phone. And when they see a new kind of blob of data being posted by a rollup, they request random samples of it. And once they do enough of the sampling, they will be sure enough that, okay, I've asked such random chunks of data that it's almost impossible that the rollup has withheld any of that data. Let's see. So adding n nodes to the Ethereum validator set does nothing to increase the scalability of this data posting throughput from rollups. Whereas on Celestia, because you can have multiple kind of services randomly sample this data at once, it means that throughput increases. And actually, because of how data availability sampling works, it actually increases quadratically. Like if you add n nodes, you have then n squared more throughput or something like that. Yeah, and Celestia can do all of this using light nodes, which are very low in hardware requirements and network connectivity requirements. And when you have more light nodes, you can have data checked faster because of this sampling. When you can more quickly check a block because you have more nodes, that means that you can increase the block size and still have it checked in the same amount of time that you did before. So you have higher throughput. So Celestia scales even with increased demand as long as people run more light nodes. And these are some screenshots from Twitter, people running Celestia light nodes in various settings. Like there's someone who ran it on their, ebook reader. Someone who was in the outdoors and ran it on their phone and it runs just fine, or in McDonald's, all sorts of places. So just to prove how low of a resource requirements it has. And if you're familiar with the Ethereum roadmap, you might know that, okay, but soon enough, Ethereum said they're going to do this as well, so why even bother to use Celestia? In this spring, we have an upgrade coming to Ethereum called the Denkun upgrade, which brings this feature, EIP 4844, the ability to post blob data that will only live on Ethereum for 3 months. And if you remember, this is what Celestia does as well. But the difference is that there is no data availability sampling. So you still have to go through the entire blob of data that's being posted. And there's no way to scale this by adding more nodes, as opposed to what Celestia is doing. Yeah?
Do you know the reason? Is it like a technical reason or like a political
Yes.
reason that was decided not to do it? Or is it just impossible to do it?
No,
and
no.
They went another different way.
No, actually, they know this is the way forward.
Okay, so this is the plan, but they can't, they're going to do it.
Yeah, there's so much legacy in Ethereum that it takes lots of changes to consensus and stuff. This is why basically Celestia was able to innovate so quickly, or come with the product so quickly, is because there's no legacy from the Ethereum chain. It's a specialized blockchain, they could optimize everything to the max to provide data availability, right? Yeah, and so data availability sampling is on Ethereum's roadmap. It's called dank sharding. This upcoming upgrade, EIP 4844, this is called proto dank sharding. But it's years away as far as we know. Yeah?
Will this make transactions on Ethereum cheaper, the upgrade?
Sorry, I was on a flight today and I don't hear very well the year because...
Will this make the transactions on Ethereum cheaper?
It will. So this will already make basically roll-up transactions cheaper. Ethereum transactions will still be just as expensive, But rollups that use Ethereum for data availability will become cheaper. Some say that 10x cheaper. We'll see. So that's a benefit to rollups rather than to the layer one.
I've got a question as well.
Yeah.
Is it only temporarily stored on Ethereum just because it's only needed in that transfer process for settlement, then it's not required?
Yeah, exactly.
But isn't there like blockchain, like the permanent record?
I like this
feature
question.
that you're kind of like removing that might be actually needed later if it got stolen or something?
Yeah. I think this is more of a philosophical question than, because there's always a trade-off. But
For example,
I think,
if somebody like was in DeFi, staked something, and then something went wrong and they lost that,
yeah,
and then they had an insurance maybe on that staked stuff, then they'd have to find some kind of
Yeah.
breadcrumb back to your
yes,
roll-up, right?
yes.
But it's on Ethereum, so do you have some kind of like reference to your own data that you can cache kind of a thing?
Well, so there's still historical nodes that are going to be around, but those are not really enforced. They're not part of consensus. Like, what's for sure going to happen is that centralized entities, well, they're already storing all of this, and they can provide you with that data at a cost. Or like, yeah, basically the assumption nowadays is becoming that Ethereum is enough to decide, or like any chain, is enough to decide on the state transition between yesterday and today, and we're trying to make that really secure. But then keeping track of what came before that can be done by someone else. Like, we shouldn't burden the network validators with having this bloated state, as long as we have a way of securely deciding, or like securely transitioning from one state to the next, if that makes sense. Like, maybe if you're more security minded, you could take that data yourself and post it to IPFS, and I'm sure there's people who will. But kind of the conclusion that everyone's converging on is that we shouldn't actually keep that much historic data on the chain, because it's just too expensive to have if you also want to have it properly decentralized and high throughput.
If I may, second question. So when you've got a roll-up from, like, let's say Ethereum to Solana, right?
Yeah.
You wrap it, it goes across, gets unwrapped, yeah? Now before you said you had like a little image, you had like the smart contract on each side, yeah? So each smart contract is calling the other contract to interact with, right? And then when it's okay, then it's all consensus approved. Is it considered like a deployment of a new contract when it's confirmed that they burned that roll-up, for example? Is that like, is it classed as like a new deployment?
So you mean,
Because it has a new input feed saying from the other smart contract on the other chain saying, yes, it got burnt, and now you can give him this, that's a settlement thing, right?
so point is, you can send authenticated messages from one rollup to another using kind of like any general message passing bridge. And if you want to be able to deploy a contract on a foreign rollup from one where you have an account, you could do that as long as you have another contract that kind of takes in the right call from you that's authenticated and deploy, like a factory contract, and deploys it for you.
Okay.
Hope that's what you're asking.
But like, the question was like, is it considered a new deployment because it has this like, it's just basically two smart contracts.
You mean Hyperlane, like when you deploy it?
Yeah,
or?
Hyperlane, they both exist, the smart contracts,
Yeah.
and then the bridge just kind of triggers the inputs for each other to say, yes, we finalized, and yes, we received, right? Triggers on each side, and then the completed. Done.
So when you deploy Hyperlane afresh, it's a whole new set of contracts. And like, say you have Hyperlane run a bridge from Optimism to Arbitrum, but you actually don't want to use the Hyperlane bridge because you think that it's centralized or something. You could take our open source stack and deploy it yourself, and you deploy, again, a whole new set of contracts that lives in parallel to the ones, say, owned by the Hyperlane DAO, if there will ever be one, and run that yourself. But yes, it is a separate deployment. Yeah.
Are you gonna, I think there was like a Solana Ethereum bridge mentioned.
Yeah.
Is that something that you'd consider integrating with as well? Because it's like.
So we do have a live bridge. Actually, I'm almost done, and then I'll take questions, just so that we don't go off topic. Yeah, and so basically data availability sampling is coming to Ethereum within a few years, but like rather than wait for that, you can use Celestia for data availability, and that's live today. Like you can start lowering fees of your rollup today. To recap, you have the modular stack, Celestia fulfills consensus and DA, Hyperlane fulfills interop, and so then you have these two layers where you can really kind of innovate. And there's people kind of innovating at the execution layer. Like we no longer want to use the EVM, we want to use the Solana VM, which you just mentioned. So basically we can have a Solana VM that executes transactions, a contract on Ethereum that deals with settlement, and then Celestia that's kind of a Cosmos chain deal with data availability. Like you can really mix and match these things and optimize them. And to give you a concrete example, has anyone here heard of Manta Pacific, which is this layer 2? It's a very recent layer 2, and I think they ran this campaign, and as of today, they're the third biggest layer 2 by assets locked. And they switched data availability from Ethereum to Celestia to lower fees. And this actually lowered fees, again, messed up fonts and all, but they lower fees by 100x. So I think the transaction before the switch was like $0.3, and now it's like really, really low, right? By using Celestia for data availability. And besides that, they used Hyperlane for their TIA to Manta bridge, like to bridge Celestia, like the native asset of Celestia to Manta. And this wouldn't have been possible with any other bridge provider so quickly. And this bridge is live today. It's called Nexus, and you can find it as usenexus.org. And that's it. That's the presentation. If you want to learn more, we have docs, all sorts of socials links, and we're hiring in London and New York. So now if you have any questions, happy to take them. Yeah?
You use relays, but who's running the relay? Are you running them yourself or Abacus?
Yeah, good question. Like the relay is a permissionless element. No, it's a permissionless component. So anyone can spin up a relay, but this isn't a trusted thing. It's just like to pass messages that are already authenticated by whichever security module you pick. So you could like relay the messages yourself manually, or yeah, we run a relay, but you can run one as well if you wanted to.
How do you manage multiple relayers at the same time, not to take the
Yes, good question.
the same message and not messing it up?
Yeah. So the way it basically works is that when you, let me go back to the diagram. The way it works is that when you call the mailbox contract, you also select the relay that you want to pay at dispatch time. And you can pick a different relay. There's one selected for you by default, which is the Hyperlane one, but again, that's not a trusted thing. You can change it.
I have one last.
Can you use the microphone?
Yes.
So we hear you in the recording.
Okay. And you said that the relayer goes around like checking the mailboxes. What's the delay, or it's not a push to the relayer, right? It's on
no.
wait. It's on a time delayed base, right?
I mean, yeah, as delayed as the providers that we connect to are. So the way the relayer works is that it connects to these RPC endpoints of various providers. We actually use several of them. And it subscribes to kind of every new block, or makes, actually I think it's pull, yeah, it's not push. And every few seconds it checks if there's a new block, and then it will make this query. In Ethereum it's ETH get logs, an RPC call, to see all the events that happened in the last block, and then filter based on the mailbox events. So honestly I think it's maybe a couple of seconds at most delay, but this also depends on the provider. And the biggest issue of actually running a bridging product is dealing with RPC inconsistencies or unreliability. This is bigger than, at least in my experience, than any smart contract challenges. I'm a Rust engineer. I actually work on the agents, so
Okay.
I get a lot of that.
Yeah. Okay. Thank you very much.
Yeah.
Wait.
Is there any incentive to run your relayer, or the other way around? Is there a way that, let's say, you want to be a malicious agent on the ecosystem? So what's the trade-off there? Why I should run something? What I'm getting for, right? I'm using CPU, I'm using memory, so.
Yeah. Well, so as I said, when you dispatch a message to the mailbox, you attach maybe your tip for the relayer in that call. And if you've selected a malicious relayer, you may have paid them, but then they can choose not to deliver your message. And in that case, you've kind of lost the tip. But this is an assumption we're fine with for now, because presumably you're not going to pay them that much to relay your message. So that's, you could consider a denial of service vector, but this is why we're saying that in the future we want to have this serviced relayer approach where you can track the reputation, very similar to proof of stake nodes, right? Yeah.
Hi.
Hey.
Thank you. So you mentioned that relayer are not trusted.
Yeah.
Can you argument more about how they are not? How do you authenticate messages for relayers?
Yeah. Well, messages aren't authenticated. Like anyone in theory can choose to deliver a message that's been sent to this mailbox and just do it manually or whatever to this other mailbox. To protect against message replay, we have a nonce that increases with each new message. Like if you've actually worked with any sort of Web3 wallet or something like that, whenever you send a transaction, say with MetaMask, your first transaction ever will have nonce number 1, then your second transaction will have nonce number 2, and this is included in the transaction data when you broadcast it, so someone cannot replay it, right? And we do something very similar to messages in the mailbox. So like the first message ever to arrive in the mailbox is 1 and 2 and so on. And there's no authentication involved with the relayer. Like in theory, you could have 10 relayers try to deliver your message. Only the first one that gets their transaction through will succeed because of the nonce, and the rest will fail. But like in practice, no one's gonna deliver your message for free, because when you call the mailbox here, you have to pay a transaction fee, which is why I said that you pick your relayer at dispatch time because you pick the one service you want to pay. But like, yeah, if they decide not to deliver your message, you could do it yourself basically and not be locked by that choice, right?
Okay. And how do I trust the message in the mailbox of chain A? Because I see there the validators you mentioned about the security modules.
Yeah.
So it sounds to me that you can define the level of trust you want on that specific message.
It's in practice the receiver who defines it. But yeah, well, when you send the message, you're obviously not going to send a malformed message. It's in your best interest not to. Or like it could be the dApp that's integrated with Hyperlane that does that for you. But like I would assume the message is correct. And then yeah, if you are to use the validators, what we do is that every message in the mailbox is added to this data structure called an incremental Merkle tree that kind of stores all of the messages ever added to the mailbox. And if you decide to use like a security module based on the validators will have to sign both the nonce of that message and the Merkle root, so that you know that they're not just saying, oh, this message appeared. Like there's also this Merkle root. And if you use economic security, so again, I'm not super involved on the smart contract side, but if they, it's something like if they don't sign a message and it was there, given a long enough gap, they get slashed for it. Or like because you can check using the Merkle root.
Okay. Last question.
Yeah.
Are those validators the validators of the chain or validators that are engaged with the Hyperlane protocol?
it's fully up to the receiver. So we have a contract factory called the multisig, ISM, like the multisig ISM. And when you deploy a new ISM, you can define your multisig set and your multisig threshold. So basically in the set, you have all of the addresses of the validators that you require a signature from. And then the threshold is like how many validators need to have signed this in order for the transaction to go through. And then it's up to the receiver to select this. It could be the way IBC does it. So basically you require all of the validators of your origin chain to do it. Or it could be like some established providers that you trust. But the really nice thing about how all of this works is that you could start with a 1 out of 1 multisig or 2 out of 2 because you're just starting out. You don't need that much security. It's more like for testing. And then as time goes by, you can go for a stronger and stronger multisig. Then maybe in the meantime, you convinced Wormhole to deploy, and then you'll use Wormhole. Or like eventually have a native verification bridge that's wrapped. So like you can start from the most basic thing and then gradually upgrade it. Yeah.
So you talked about wrapping Wormhole, but
Yeah.
You can wrap any bridge, other bridge, basically. Is that what you say?
Yeah. This is something that I've not covered in these slides, but with our V3, which is the latest version, we have this thing called hooks. And the hook is basically a contract that lives on the origin and an ISM, a security module on the destination. And when you dispatch your message, you specify whether you want to go through one of these hooks. And so you can have a Wormhole hook. So you dispatch your message. Then the mailbox calls into the Wormhole hook, which will then call into the Wormhole send contract. Wormhole will then use its infrastructure to send your message to the Wormhole ISM, which is then specified by your receiving contract. And then, if it's been received in the Wormhole ISM, then the mailbox will forward it to the receiver. Yeah. So we hope for this to be the end-all, at least interchain UX for bridging. Yeah.
Hi again. So when you send the message to the mailbox, you choose the relayer, but after you chose it, then you cannot relay your own message, right? It's locked.
You can.
You can?
You can. It's basically you choose who you want to pay for sending that message. So there is another contract on the origin called the interchain gas paymaster. It doesn't really matter. It's one contract per relayer, and you pick which one you want to pay based on the relayer who you want to have relay your message. But if this relayer misbehaves and isn't sending your message across, you can still kind of make the call to the mailbox yourself manually, what the relayer would have done for you. There's no authentication going on. It's merely a contract you choose to pay so that someone will be incentivized to call a function on another blockchain.
Okay, but so that means that only the owner of the message can relay it themselves, or another relayer can also pick it up and try to relay it?
Yeah, anyone
and
can.
is it a time threshold for other relayers, or how does it work? How are they not fighting for the same messages? Or if they see, for example, a high tip and they're all fighting to relay it, so how do you block that?
It's because when you make the payment to send the message, you again send your relayer tip to one contract, and that's per identified relayer. Like if another relayer will deliver a message before the one you chose, they don't get the tip. It still stays with your initial relayer.
So, but if I relay it myself, then the contract will see that it's already relayed, and they don't get any tips anyway, right?
So this is why I said that there is one trust assumption here. When you dispatch your message, if you choose to include a tip, that tip will be received by the relayer no matter what they do. So even if they don't deliver, even if you end up delivering yourself, they still get that because you made the payment on the origin. Okay. Like it's not tied to the outcome.
Okay, thank you.
Yeah.
So basically, relayers are optional.
They're fully optional, yeah.
You could definitely
Do it
configure your
yourself.
message.
You could have your own service to do that for you.
Right.
It's, yeah. Yeah.
So yeah, I'm just thinking about like what you said before about chain B being the ones that decide the level of security that's requested from the validator, the number of nodes that can
Yes.
join the consensus on that. So just thinking about like the future of tokenized markets globally and who might be using these roll-ups in future, like the scale of it, you know. It's interesting, like, so there's no way then that the person on chain A can like emphasize how much security they want to provide to someone for their kind of peace of mind, because what it seems to be doing, what you said that they decide is, it's gonna maybe incentivize in future when they have competition doing the same thing. It might incentivize less security to issue an asset on the other side. So I don't know. It's,
That's a very good. That's a very good question. Well, there was a slide which I took out. Now I kind of regret it. But you could have your company or product own both the sending and the receiving contract, and then it's up to that deployment to set its own security. And like, actually, our approach to token bridging is different from other providers. Is that others have just one single contract where you send all of the funds to, like, be it an ERC20, an NFT, or whatever, all of them are sent to the same contract. Whereas for us, one token route is a separate bridge from another route. And you can have different security per route. And the point is that, say the sending contract is the one you send your USDC to bridge, and then the receiving one will be the one that mints your wrapped USDC. It makes sense to define security as part of this USDC route, but maybe for a different token, you do want a different security. But like, given that in most cases you will be owning, or like the dApp will be owning both contract instances, that's actually not really an issue, because they're both on the same page given what they want. And you can have, again, parallel deployments of the same bridge layout for different purposes. So then if you want to go via the very secure route, you call into the very secure sending contract. If you want to go via the less so secure route, you go via the other one.
So you can choose a little bit like the level.
You could, yeah.
Okay. Thank you.
Cheers.
Anyone else?
So you said that onboarding like a new chain is quite easy. So I guess it's only creating one contract in that chain, and then it's already connected, like has the information for all the others, right?
It's a lot of deployments. We have a CLI. It's called the Hyperlane CLI, and you can use it to deploy a chain really easily. Like I did it when it first launched in November, between Sepolia and this other network called Ancient 8, and it took me like 10 minutes to do it on hotel Wi-Fi. But there's a lot of contract deployments involved, because like there's a whole set of contracts I haven't mentioned here. So costs, like upfront costs, might be quite a bit. Like, yeah, I'm not sure of the exact numbers, but it's quite a bit. And then once you do that, once you deploy all the contracts, you need to spin up the infrastructure for the bridge to work. So basically, you need to run your own relayer. If you're using a committee like a multisig, you need to run your own validators or convince others to run the validators. But there's these two pieces: deploying the contracts, configuring them with one another, like enrolling them, and then spinning up the infrastructure.
Okay.
So maybe 3 steps.
Thank you.
It did. With the CLI is really, really cool. It's new, like we've not really advertised it before, but it's very powerful.
Okay, so anybody could deploy like their bridge technically from any chain to any other chain in 10 minutes.
Yeah, like the first step, if it's 2 completely new chains that no one has heard about before, you need to fill in some details like the ones you'd be completing in MetaMask, like the chain ID, an RPC to use when deploying contracts, and a couple other details. It will then deploy the contracts between them. It will also configure them for you, and it will output some artifacts like JSON files that you can then use to spin up these services like Relayer and Validator. And we actually partnered with a product called Kurtosis that runs stuff in the cloud, and you just give them your JSON artifacts, and they will just spin the infrastructure up for you. Like even more than that, the Hyperlane CLI can read those artifacts for you and generate a URL. You just click that URL and complete, like fill in a form with the private key you want to use for the relay and stuff, and it just starts it for you, all pre-configured with all the chain details, all the contract addresses, everything else.
Cool.
Yep.
Can you move like, because it's like Ethereum virtual machine, Yeah, because it's EVM compatible, can you move like any ERC standard across your bridge?
Yeah, absolutely. Like the Hyperlane protocol is just a specification. You can, so is your question, can you bridge cross VM or cross standard? Or
like, you know, the ERC standards, like this new one you were saying, well, it were any different one, but can you move, for example, an NFT across this bridge that's an ERC 721 or something like that?
So as far as I know, we have support for 3 ways of bridging, and it's exactly that. It's ERC20, ERC721, and the native bridging. And native bridging, like Ethereum, so you get wrapped Ethereum on the other side. Yeah.
But if you're moving like an NFT, so you are burning and minting, or you're just sending it to the same wallet address?
So fundamentally, this is a message passing bridge, right? You can send whatever you want through it. Hey, and like, it's really up to you to configure the way you do token bridges. There is one client we have where we do, I think, like burn and mint, but like most of the bridges are lock and mint. So
okay. Yeah, that makes more sense.
Yeah,
okay.
yeah.
Thank you.
All right. I guess, we're going to stop. Can you carry on the conversation?
Yeah. Thanks a lot for having me. Cheers. Thank you. Let's go. Go modular, yeah?